want to take a look at equations that are reducible to quadratic form. Sometimes they're referred to as quadratic type equations. And the thing is, they're pretty much usually going to have three terms in them, and they can be written as an AU squared plus a BU plus C if we would appropriately substitute something in the equation. We're going to solve these basically in two ways. I like to do factoring as it is, if I can, and if it's too messy looking, the original exponents are kind of fractions or weird things, then I'm going to go ahead and use the substitution, letting u be whatever the middle variable part is. All right, and we'll see that in the next example. The first one, they're very nice exponents here. This x to the fourth minus 5x squared plus 4, that looks like something I should be able to factor, kind of unfoiling. And the thing I have to remember is whatever I put in the first two spots have to multiply to give me this first term. So I'm not going to use x and x, I'm going to use x squared and x squared to get my x to the fourth. Jump over the middle, go to the last, and I need something times something to get me a positive 4. Well, it could be 2 and 2 or 1 and 4. Because I'm going for a 5 in the middle, and I need both of these to be the same sign, I'm going to try the negative 4 and negative 1. That'll give me the positive here, but give me a negative 1x squared, negative 4x squared, or total of negative 5x squared for the middle. Right, now, the property that we've talked about before is a zero product property. It says if something here times something here is equal to 0, that means either that first something, x squared minus 4, is equal to 0, or the second one, x squared minus 1, is equal to 0. Now, this just has a nice x squared in it. Okay, so it makes sense to just solve for the x squared and take the square root. So add the 4 over to both sides, take the square root of both sides, and remember that you get a positive and a negative square root, so a positive 2 and a negative 2. When you come over here, you're going to add the 1, you're going to take the square root, and you're going to get a positive 1 and a negative 1. So you see a total of 4 answers. Now, if you were to graph this in your calculator, which you might want to do on a test, you should see 4 x-intercepts or 4 zeros there. Now let's take a look at the other type of quadratic form or quadratic type equation that we're going to run into. These are going to have kind of weird fraction exponents or maybe square roots in them or something like that. If it's not something that looks like you can just look at it and factor it like that last one, then take the variable part here of the middle term and make that your u. Okay, so u is equal to x to the 1/3. Now it's going to work for us as long as when I square both sides, I get this first term for this for my u squared. So if I square the u squared here, and then over here I square this term, properties of exponents tell me power raised to a power you multiply, and we do get our 2/3. So this is going to work. So I now rewrite it in terms of u, and that looks like really simple to factor. So u minus 8, u plus 3, setting them both equal to 0, and we get u is equal to 8 and u is equal to negative 3. But we're supposed to be solving for x. So we go back up here and we look and say, what was u again? Oh yeah, it's x to the 1/3. So I put x to the 1/3 is equal to 8, and x to the 1/3 is equal to the negative 3. Now what is x to the 1/3? Well, we've had rules for exponents before that tell us the fraction exponent is really telling me I've got a root, and the denominator of the fraction is the kind of root. So in this case, the x to the 1/3 is really the same as a cube root, and I would cancel that out by raising to the 3rd power on both sides. So we get 512 on this one, and the negative 3 cubed is going to be a negative 27.